2, 1, ignition, and liftoff.
We've grown used to wonders in this century. It's hard to dazzle us. But for 25 years, the United States space program has been doing just that. The Challenger crew was pulling us into the future, and we'll continue to follow them.
It was called the National Advisory Committee for Aeronautics, a new independent agency created by President Woodrow Wilson in 1915. Its job, make the United States a world leader in the field of aeronautics. In less than 3 decades, these early pioneers in aviation and those who followed would be called upon to think through problems a million miles away and do it with boldness and vision. By the mid-1950s, NACA had modern wind tunnels and was moving into the area of rocket and satellite research. Then on October 7th, 1957, the U.S. and the rest of the world were greeted by the sounds of Sputnik 1. The Soviet Union had placed the first artificial satellite into orbit. It would not be until early the following year that America's satellite, Explorer 1, successfully orbited the Earth and discovered a dense belt of radiation surrounding our planet. Who would have believed at this early stage that we would one day move outward from the thin ribbon of Earth's atmosphere to the very edge of our solar system and beyond? Project Mercury, the country's first manned spaceflight program, was given the go-ahead just 1 week after NASA was formed on October 1st, 1958. Seven test pilots were selected to become astronauts. Donald K. Deke Slayton, Alan B. Shepard, Walter M. Schirra, Virgil I. Gus Grissom, John H. Glenn, Jr., Leroy Gordon Cooper, and Malcolm Scott Carpenter. The 7 new astronauts spent months and months undergoing rigorous testing and training. While they were being trained, several monkeys took check rides in the new Mercury spacecraft. Meanwhile, the orbiting of unmanned satellites became more and more commonplace. And weather watchers like Tyros found a permanent place in our daily lives by improving weather forecasting capabilities. On August 12, 1960, President Eisenhower took part in the first transmission of the Echo 1 communications satellite.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as Echo.
On May 5, 1961, astronaut Alan B. Shepard made America's first suborbital flight. Project Mercury was underway.
All right, lift off and the clock has started. Yes, sir, reading you loud and clear. This is Freedom 7. The fuel is go, 1.2 G. Cabin at 14 PSI. Oxygen is go. Cabin pressure is holding at 5.5.
Soon after Freedom 7 landed, President John Kennedy gave NASA an ambitious new space goal.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
After Alan Shepard and Gus Grissom's test flights, 4 other American astronauts orbited the Earth in Mercury spacecraft, starting with John Glenn. He was followed by Scott Carpenter, Wally Schirra, and Gordon Cooper. As NASA geared up to respond to the lunar commitment, it became clear that new management techniques for handling far-flung systems manufacture and final integration would have to be developed. Clear also was the fact that state-of-the-art electronics and computers would be pushed to the limit. Unknowns about the moon were numerous. Such things as whether an astronaut would sink into dust over his head were a real concern. Lunar impact studies like these were carried out in an attempt to learn. Researchers fired projectiles simulating meteors hitting the moon into sand-like and rocky materials, and then measured how much material was thrown out by the impact. This animation shows how scientists believed the huge crater Tycho was formed on the moon, a crater 54 miles wide. A series of picture-taking Ranger spacecraft slammed into the moon. Then, 5 lunar orbiters photographed over 90% of the moon's surface, including the never-before-seen backside. We saw a glimpse, too, of our own planet from lunar distance. But most important of all, it made possible the selection of landing sites. 6 Surveyor spacecraft made soft landings on the moon over a 2-year period. A robot arm dug a trench. Lunar soil was like wet sand. Men and equipment could safely land there. Panoramic views like these were assembled from hundreds of individual photographs. Communications via satellite exploded into a whole new industry. That first live intercontinental transmission by Telstar 1 was just the start.
La chansonnette après l'épée.
Relay, designed to transmit television, telephone, and high-speed data. Syncom, with Olympic coverage from Tokyo, and Early Bird 1, all were follow-ons to previous research and development.
5, 4, 3, 2, 1, take it.
Because of the following special one-hour broadcast, programs previously scheduled at this time will not be seen.
Since rendezvous, docking, and having astronauts work outside the spacecraft were critical to lunar missions, NASA began Project Gemini. Using the Mercury capsule as a model, the Gemini spacecraft was enlarged to hold a 2-man crew. Gemini would provide design answers for the upcoming Project Apollo. And who could ever forget that spectacular first walk in space made by astronaut Ed White? Ten times pairs of astronauts flew into orbit, walking in space, rendezvousing, and docking. Gemini had blazed a trail for Project Apollo, the 3-man spacecraft that would carry astronauts to the moon. More than 8 years were poured into designing, building, testing, and preparing astronauts, rockets, and spacecraft for the first lunar landing. Here's a visual look back at some of that preparation. In 1967, tragedy struck. The nation mourned the loss of the crew that would have flown the Apollo spacecraft on its maiden voyage. Astronauts Gus Grissom, Ed White, and Roger Chaffee died in a flash fire as they were conducting pre-flight tests on the launch pad. The manned flight schedule was delayed 18 months as the command module underwent redesign. While these changes were being made, the parts and pieces needed to assemble the giant Saturn V moon rocket came together at the Kennedy Space Center, Florida. Everything associated with the Saturn V was huge. The rocket itself, the building where it was assembled, and the crawler transporter that carried it to the launch pad. The fully loaded Apollo Saturn V was 363 feet tall. Its main engines alone generated 160 million horsepower, and its fuel pumps pushed fuel to the engines with the force of 30 diesel locomotives. As Saturn V lifted off Launch Complex 39 for the first time, it weighed more than 2,800 tons. The pace quickened. Starting with Apollo 8, every Saturn V launched had a three-man crew. Two days before Christmas in 1968, astronauts Borman, Lovell, and Anders became the first humans to pass out of Earth's gravitational control and into that of another body in the solar system, the Moon. The hardware to travel to the Moon had worked well, and landing sites looked good. Our Earth seemed small and fragile, hanging in the vastness of space. This view of ourselves from lunar distance would change the way we think about Earth for all time. It raised profound questions, especially those associated with the Earth's finiteness and unlimited resources. The next two flights, Apollos 9 and 10, would continue dress rehearsals for the first lunar landing. All systems were indeed ready. Astronauts Neil Armstrong, Edwin Aldrin, and Michael Collins would make the historic journey. Next stop, Tranquility Base.
2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Tower cleared.
We got a roll program. Neil Armstrong reporting the roll and pitch program, which puts Apollo 11 on a proper heading. Houston, Apollo 11 is calling you on the high gain. How do you read, over? Roger, loud and clear on the high gain. Eagle, you're looking great. Coming up 9 minutes.
We're now in the approach phase. Everything looking good. Altitude 4200.
Houston, you're go for landing, over. 40 feet down, 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drifting to the right a little. 9.5. 30 seconds forward. Good. 8.
Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
Across the country and around the world, the Apollo 11 crew were welcomed back as heroes. Meanwhile, more than 100 scientists from here and abroad began intensive studies of the lunar samples. Before Project Apollo ended, 6 additional flights to the moon were made, and all but one were highly successful. Skylab was the next manned spaceflight. Launched first was a 2-story orbital workshop. Then the first of 3 three-man crews departed to meet, join, and begin living in the orbiting laboratory. Those crews would stay 28, 59, and 84 days respectively. One of the major objectives was to find out if astronauts could physically withstand extended stays in space and continue to do useful work there. The answer was a resounding yes. Experiments in astronomy, Earth resources observations, materials processing, and crystal growth all proved highly successful. Then ASTP, Apollo-Soyuz Test Project, a joint endeavor between the Soviet Union and the United States. The mission called for a mutual docking and crew exchange to develop the necessary equipment for international space rescues. The years of research and development would now be put to the ultimate test. the first flight into space of Shuttle Columbia with astronauts at the controls. There was an air of excitement as the brand new shuttle moved from its processing facility at the Kennedy Space Center to the vehicle assembly building, where it would be mated with rockets and fuel tank and rolled out to the launch pad. Never before had a new spacecraft been flown this way. Previous Mercury, Gemini, and Apollos were man-rated in advance, meaning that unmanned flights were flown before putting an astronaut crew on board. Despite nagging problems with engines and protective tiles, there was a quiet optimism. Longtime space workers knew from past experience with the lunar landing program that design and engineering problems do get worked out. After one false start, astronauts John Young and Robert Crippen headed for the launch pad.
30 seconds. That goes into the interior, and the astronauts are required.
Columbia's maiden flight would be brief, just 54 and a half hours, 36 orbits, and return to Earth. But it signaled the beginning of a reusable space transportation system.
To ensure that everything is in the proper place.
10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start.
Roger, Columbia. You've got your normal Capcom back now. Okay. The only bad part about it, Joe, is we're going to have to come down. Three, two, one, down.
Look at the sand! Look at the sand!
That's a good picture done coming down. Right, Roger. I'm going to wait for Doctor. Went overboard first.
30 weeks later, after Columbia had been returned to the Kennedy Space Center, cleaned, refurbished, and rolled out to the pad, astronauts Joe Engle and Dick Truly flew Columbia into space again. While an imaging radar system mapped distant Earth, the crew made a critical test of a Canadian-developed mechanical arm that would later place payloads into and out of orbit.
Okay, we copy. Thank you.
Looks like it's a little cloudy out here, Stanley. It's a good thing the Sir AC did that. And we can hear it crank up on the board.
Okay, stand by. Okay, we see fan A on, and we'd like you to take Bravo.
As Columbia landed the second time, the circle was complete. A new generation of space travel had begun. when Space Shuttle 3 left the launch pad, it carried an experiment prepared by 18-year-old Todd Nelson of Rose Creek, Minnesota. An experiment to study the effects of weightlessness on insects in space. It's called the Shuttle Student Involvement Project and includes NASA, the National Science Teachers Association, and industry sponsors who help transform winning proposals into flight experiments. Since this first flight, young people in high schools around the country have developed and flown a variety of experiments, ranging from medical projects to the study of zero gravity on an ant colony. They are setting an example for others who may be encouraged to pursue careers in science and engineering, something that ultimately can be translated into technological leadership for the U.S. 12 weeks passed. Then astronauts Ken Mattingly and Henry Hartsfield piloted Columbia on its fourth and final test flight. The spacecraft's performance made it possible to certify the Space Transportation System a fully operational carrier. As they landed on July 4th, the crew was greeted by President and Mrs. Reagan. Space Shuttle 5, the first operational flight. 2 commercial communications satellites were hauled into orbit, one for satellite business systems and one for Telesat of Canada. Their deployment was a complete success.
Did you get it? You don't have it, obviously.
I got it.
Space Shuttle 6 was the second operational mission and Flight 1 for Challenger, this country's newest spacecraft. After launching a 5,000-pound tracking and data relay satellite from the payload bay, mission specialist astronauts Story Musgrave and Donald Peterson became the first Americans in 9 years to walk in space. Practice needed for satellite repair work.
I do for my massive article, rotate around and get it on the right side.
Roy,
Yeah.
big caddy up here where it says tape on the left-hand door.
Yeah.
Mission 7 carried a crew of 5 into space, including America's first woman astronaut, Sally Ride.
Main engine start. We have main engine start and ignition and liftoff. Liftoff of STS-7 and America's first woman astronaut. And the shuttle has cleared the tower.
She and mission specialists John Fabian and Norm Thagard deployed a pair of communication satellites for Canada and Indonesia.
They got colors like this.
Roger that. Looks great.
Shuttles 1 and 2 were now operational, with the addition of a third orbiter, Discoverer, to the fleet, and with literally dozens of astronauts in training at any given time, this new space transportation system would begin delivering in earnest and with increasing frequency.
"17 shuttle missions were flown in the next 2.5 years. Here's some of the highlights. This is the first use of the Manned Maneuvering Unit, or MMU, on Flight 41B.
Okay, here we go. All this may have been one small step for Neil, but it's a heck of a big leap for me. Copy that, Bruce. Thank you. Oh, this is really beautiful out here.
The objective of the mission was to test equipment and procedures for the next flight, when an ailing solar satellite would be retrieved using the shuttle, repaired in the payload bay, then returned to orbit. On the next mission, STS-41C, astronaut George Nelson again used the MMU, this time to reach the Solar Max, an ailing scientific satellite launched specifically to study the sun during a very active period, only occurring 1 year out of 11. Nelson was having trouble docking with the satellite, and his attempts were causing it to wobble. His MMU fuel was also getting low, so he had to return to the shuttle. SolarMax would be retrieved using the robot arm. But the satellite was wobbling too much to be grappled that way either. SolarMax mission controllers would have to stabilize it first.
Challenger Houston sending by through Yargity.
Okay, we've got it, and we're in the process of putting in the FSF.
Outstanding.
Repairs could now begin. SolarMax had 2 faulty systems needing fixing. First order of business was to change out the attitude control system. Next came repair of the main electronics box on one of the prime experiments.
Challenger Houston, you go for release as long as you're within 5 degrees. Roger.
Ground controllers then checked out the satellite to make sure everything was working properly. Then it was redeployed to continue its mission. On Mission 51A, the objective was to retrieve 2 inactive satellites, then return them to Earth in Shuttle's cargo bay for repair back home. A newly developed Stinger device allowed astronauts to dock with the satellite so they could stop its spinning.
Stop dock, stop dock. Stop the clock, we've got time. Let's go get it, Anna.
Then the robot arm could bring both astronaut and satellite safely into the payload bay. There, a coupling device that the arm could grapple would be attached to the satellite, keeping it stationary during berthing. But the A-frame didn't fit. There was an obstruction on the satellite. Plan B was put into effect immediately. An astronaut would hold the satellite while another secured it in place. For the second stowing, the astronaut held the satellite from the end of the robot arm using a space version of a cherry picker called a manipulator foot restraint.
Houston, Discovery.
Discovery, Houston.
Roger, we have 2 satellites latched in the bay.
Roger, that gave us a big cheer down here.
Missions 41B, 41C, and 51A proved that equipment, procedures, and tools for docking with satellites and repairing them in orbit worked correctly. It could be done. In addition, satellites never intended to be returned to Earth were in Shuttle's cargo bay to be fixed and relaunched in the future. So, when yet another satellite malfunctioned, it gave NASA just one more chance to demonstrate its flexibility. 51I's mission was to repair a satellite antenna, essential for communication with the ground. Then redeploy it to a position where it could reach a higher orbit.
Okay, Omni deploy fire. Omni fire, here she comes, looking good. Looking good, buddy. All right.
To accomplish this, a spin-up bar was attached so the astronaut could get a good grip.
Okay, we copy. That's great work, everybody.
I can still see the timers blinking. I hope it works. Yeah, I do too.
While a number of shuttle missions focused on satellite operations, other missions focused exclusively on scientific research. A European-built Space Lab module fits in Shuttle's payload bay, allowing as many as 100 experiments to be operated for up to 10 days, 24 hours a day. Life science research is a major area of Space Lab experimentation. Discovering the exact triggering mechanism for space adaptation syndrome, like seasickness on Earth, is crucial to finding a remedy. Understanding the effect exercise has on the human body in the zero-G environment is also important. 24 monkeys were studied on board Space Lab Mission 51B. From the altitude at which shuttle orbits Earth, very accurate observations of the sun and astronomical objects can be made. This is the Aurora Australis as seen from space. The most unique aspect of Space Lab is the ability to provide scientists back on Earth the result of their experiment as it happens. As the mission unfolds, data can be analyzed and adjustments can be made. Many different fields of scientific research can be accommodated in Space Lab. Even gardening.
And here comes the flight crew now. Commander Dick Scobie, followed by Mission Specialist G. Resnick, Ron McNair, and pilot Mike Smith, followed by Krista McCullough, teacher in space, Ellison Onizuka, and payload specialist Greg Jarvis.
The tragic loss of Shuttle Mission 51L on January 28, 1986 will be remembered by Americans for many years to come. After the disaster, NASA immediately began rebuilding the space program. The faulty solid rocket booster that caused the explosion was redesigned and retested. Although no problems were found with the main engines, they were retested and certified for flight during the almost 3-year period the space program was grounded. A new flight crew was named and began training.
Okay, I'm here. 3-4. There you go.
One of the other shuttles in NASA's fleet was prepared for flight, and construction began on a new space shuttle, replacing the one lost on Mission 51L.
I have pulled the technical community, and you will have our consensus to proceed with this launch. Good luck and Godspeed.
On September 29, 1988, NASA was ready to return to space.
Auto sequence start. Discovery's 4 redundant computers have assumed T-minus 23 seconds and counting. The SRB nozzle profile.
Flight crew, close visors. Open
T-minus 15, 14, 13, 12, 11, 10. We'll go for main engine start. 7, 6. We have main engine start. 3, 2, 1, 0, and liftoff. Liftoff. Americans return to space. Discovery clears the tower.
Roger roll, Discovery.
Pilot Richard Covey describes the ride up.
Whether you have flown aboard the shuttle before or not, you are never really quite ready for the launch experience. Emotions, adrenaline, sight, sound, and motion all weld together in an overwhelming bond. Your body tells you that something very powerful is propelling you and leaves no doubt that you are going somewhere very fast. As we pass through the region of maximum dynamic pressure, the seconds seem to move ever so slowly.
Discovery, go at throttle up.
Roger, go.
Discovery giving a go at throttle up. 3 engines at 104%.
The solid rocket motors worked superbly. The long, hard work of the redesign and test teams had paid off in a perfect launch. Those motors burn for 2 minutes, but it takes another 6.5 minutes to achieve orbital velocity. The Discovery's liquid fuel engines provided the additional push required to accelerate to a speed of 5 miles a second and an altitude of 160 nautical miles. In that orbit, we would see 16 sunrises and sunsets a day for the next 4 days, traveling over 1 2/3 million miles.
3 engines still running 104%. 5,600 feet per second velocity, 31.8 nautical miles. Altitude, downrange distance, 38 nautical miles.
Main order of business on STS-26, put into orbit a second tracking and data relay satellite, originally planned for deployment on the lost 51L mission. Eventually, 3 satellites in the TDRS system will allow continuous communication between shuttles and the ground.
Good morning, Discovery! Good morning, Discovery. Rise and shine, boys. Time to start doing that shuttle shuffle. You know what I mean? Hey, here's a little song coming from the billions of us to the 5 of you. Rick, start 'em off, baby. The Hawkster to you.
On orbit is the place to be. Free-wheeling on Discovery. Earth rolling by so far below. Just give her the gas and look at this baby go.
H-A-R. Are you awake yet? B-E-Y. Why? Because it's time to eat breakfast from a toothpaste tube. M-U-double-D.
Now we're racking up the miles with a whole lot of power. We're going 17,500 an hour. Well, we can take her up high and we can bring her down low. The only thing we can't do is order pizza to go. We orbit round, round, orbit round, we orbit round, orbit round, round, orbit round, we orbit round, 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 orbit round, we orbit round, 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 orbit round, we orbit round, orbit round, 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 orbit round, we orbit round, orbit round, round, round. Till we gotta put the shuttle away. Fun, fun, till we gotta put the shuttle away. Well, we're moving so fast, but then we're hardly using any gas now. So fast now, we're moving so fast. And the odometer's spinning like a top, but it ain't gonna last. Ain't gonna last now, it ain't gonna last. Yeah, we can make it round the planet and back in just an hour and a half now. And we'll have fun, 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 till we gotta put the shuttle away. Fun, fun, till we gotta put the shuttle away.
Commander Fred Houck describes the ride down.
At about 300 feet, Dick Covey lowered the landing gear.
The gear down and locked. The report from Mission Control. Main gear touchdown. Commander Houck now rotating the nose down, standing by for nose gear and touchdown.
With only moderate braking, we stopped after about 7,500 feet of ground roll.
Wheel stop.
Roger, wheel stop, Discovery. Welcome back. A great ending to the new beginning.
Thanks a lot.
After completing the post-landing checks, we were met at the bottom of the steps by Vice President Bush, NASA Administrator Dr. Jim Fletcher, and the head of the Office of Spaceflight, Rear Admiral Dick Truly. We knew that the smiles on their faces reflected the mood of the NASA team. We'd accomplished the mission's objectives. We'd returned Americans to space.
Now NASA is ready to embark on the next logical step, a permanent presence in space. Space Station. Space station development work has been going on for many years. A shuttle flight even tested possible construction materials and procedures. Contracts have now been let for actual construction. The structure will include a platform for Earth observation instruments and observatory, servicing facility for maintenance and repair of satellites, scientific laboratory, product development facility, and crew quarters.
The space program in general and the shuttle program in particular have gone a long way to help our country recapture its spirit of vitality and confidence. The pioneer spirit still flourishes in America. In the future, as in the past, our freedom, independence, and national well-being will be tied to new achievements, new discoveries, and pushing back new frontiers. We must look aggressively to the future by demonstrating the potential of the shuttle and establishing a more permanent presence in space.